Hi there. All right, we're going to continue with our third lesson about the unit circle. In this unit, we're going to define the key trigonometric functions. So what is a function again? A function is a rule that assigns to each real number another real number. So essentially, you're given an input, and for every input, a single output, right? So in this section, we're going to define the trigonometric function. So let's review a couple key things. First, let's review, remember, the idea of a terminal point. So we're just going to call that point P for now. So we'll just say here's our terminal point. So terminal being end, right? Our end point. So we'll call this P. It has an x-coordinate and a y-coordinate. All right, so how can we find that? Well, we could describe it using the real number t. So remember, that would be our radian measure, right? So if I decided to travel along the outside of the circle to that point and stop right there, that would be t, the distance that I traveled. So that would be a radian measure. We could also think about it as degree of rotation. So I'm just going to draw a line here. So imagine we rotated a line starting at our initial arm, right? That would be the starting place. Remember how we start at 0, 0 to 1, 0, right? So our initial arm, sorry, I'm just trying to draw this line here while talking. There we go. The initial arm is right here, right? And as we rotate around from here to here, right, we could also describe it as an angle theta. So it can be a real number, or I'll write it up here, it could also be an angle. There's two ways we could measure, right? And we start at 1, 0 here, right? And then work our way around. Okay, so far that's what we've talked about. Remember, don't forget, if we have a positive value, let me just get rid of this. If it's positive, we're moving this direction, right? And if t or theta are negative, we're moving in a clockwise direction. So the big thing, let's remember how we could draw a right angled triangle in. Let me get my red pen out here and do that. Okay, so I got my right angled triangle drawn in there. And remember, what is x and what are y? X and y on the unit circle are essentially the length and width, or the height here. X is from the y-axis across, right? That is that length there of the side of the triangle. And the y-coordinate is the length here. Right now, obviously, given whether, depending on which quadrant we're in, whether we have positive or negative x and y. Okay, so that's our coordinates, right? Now, this is where sine and cosine come from. So first, let's start with the word sine. First of all, what does the word sine even mean? These are all Latin words, so they're kind of ancient English words, right? Sine is the most confusing of the bunch, really, because if you trace sine back, I've done some reading myself. It's kind of a conversion of a word to another word where it's kind of lost its meaning. So I don't think there's much of a point in getting too deep in it. But here is the definition of sine. When we're talking about a point, okay, on our circle, so I'm just going to write P. Here's our point, right? Sine is the y-coordinate. So when you do sine of t or sine of the angle, depending on, now this will be important when we're doing this later in our calculator, we have to set it to radians or degrees, depending on whether we're using radians or degrees. It's the y-coordinate, okay? So the y-coordinate here is actually found, right? The y-coordinate is equal to sine theta or sine t. I'll just write sine theta for here. So it's the distance from the x-axis vertically to that point. That is what sine is. So sine isn't something else. That's where sine comes from. Sine is defined as the y-coordinate, the vertical distance from the x-axis to the point, right? It's defined on the unit circle. This is the birth of sine. This is where sine comes from. So when you put something in like sine of theta or sine of t into your calculator, it's giving you coordinates on the unit circle. It's exactly what it's doing. So if we were, for example, to put in sine of, just for a real quick example here, if we were to put in sine of, let's do it in degrees because we're probably used to that, right? If I go sine of 90 degrees, if I were to go to my calculator and type in sine of 90 degrees and hit equals, it will spit out 1 because that's the y-coordinate at 90 degrees. Or if I was to do sine of 0 degrees, right, it would spit out 0. This is the definition of sine. This is what I need to make really clear. This is what sine is. Okay, now we use it for other stuff, but this is where sine comes from. So what about cosine? Oh, you know, before we do that, let's just write that down then right here. So in other words, your y-coordinate or sine, you could write it either way. Really, it's supposed to be in lowercase. I have a habit of writing everything in capital letters. So That's bad on me. It should be in lowercase. I'm just write everything in capitals. So sine of theta or sine of t is equal to the y coordinate. Okay, so theta and t, it just depends. Remember, we're using theta for angles. We're using t for radians. That's all. Okay, so when we say real numbers, we're talking about radian measures. All right, so that's what sine is. So what's cosine? Well, meaning, right, to go together with something, the complement, that's what is another, I don't know my Latin very well, but comes from Latin, okay, meaning the complement to sine, right? Or cos is the distance here. This is what cos is. So cos gives you the x coordinate. So if you put in cos of t or you put in cos of theta, depending on whether you're using radians or degrees, it will give you the x measurement here. So in other words, the x, the length there, is equal to cos, which we use for short, of theta. So in other words, just to clean this up, I'm actually going to erase this diagram a little bit just to make it super accurate. I've got a lot going on. Not that if you're copying along, you have to erase all this. I just want to focus on, just so I can kind of get rid of all the other stuff here. So this point is really this side here, the x side, is cos of theta or cos of t. The y side is sine of theta or sine of t. And again, just depending on whether we're using radians or degrees, right? If we're using radians, and again, when we're doing this later in our calculator, we'll have to make sure it's set to radians. The calculator needs to know, what are you using, right? When we use theta, we're generally talking about degrees. When we use radians, we're using t usually. Okay, so the complement of sine, cosine, right, is just cos for short. So cos of theta equals the x coordinate. Now again, we could replace this and also write t or t here, right? Same idea, just depends on what kind of unit we're using. All right, those are really the only two original trigonometric functions, just those two. Trigonometry is all based on this. It's all based on the unit circle. It all comes from, and again, I can't stress this enough, and I know I'm very repetitive in these, but I'm trying to hammer home this key point, and maybe I'm not as crafty with words as others, but this point, right, the x coordinate and the y coordinate here are literally just found by typing in cos or sine of that angle or that radian measure. The other four that we have here, tangent, cosecant, secant, cotangent, they all just use sine and cos. So what do I mean by that? Well, tangent, all right, which we use tan for short, is essentially the slope. Okay, so if we do tan of theta, tan is the slope of this line here, not the length, but the slope of this line right here. Think about when you find slope. What do you do when you do your slope formula, right? When we use slope, let me just write it down here. Slope is equal to rise divided by run, right? Well, what's your rise? Your rise is y. What's your run? Your run is x. Or what's your rise? Sine. And your run is cos, right? So when we're finding the slope, that's what tan is. And the word tan comes from the Latin word tangere, which means to touch, which when you start finding slopes of things, you'll notice the instantaneous slope at that moment when you're finding the tangent line is where a line that just touches that equation. So that's where that comes from, another Latin word. So tan is essentially what you get when you go sine of that angle divided by cos of that angle. So this is really just a shortcut. The tan button on your calculator really only exists as a shortcut because we could calculate it with only the sine and cos. We really only need sine and cos. Those are the only two buttons we actually have to have. We could figure everything else out from them. So in other words, instead of sine divided by cos, it's the y coordinate divided by the x coordinate, rise and run. So tan is slope, okay? That is essentially what tangent is. Okay, together, these three make up what we call the primary trigonometric functions. So I meant to have it already written in here. I'm going to try and write sideways. These are the oh boy, this is not easy. Primary, I wish I could turn this around. Primary trig functions. These three, sine, cosine, and tangent. Okay? They're the three primary ones. Now, the other three, and we're not going to get too deep into the other three because they go quite far and you can do quite a bit with it. We're not going to get into the diagram of them right now because this lesson will turn into an extremely long lesson. We're going to keep it short for now. The other three are called the reciprocal functions, okay? Oh boy, I'm not even going to try and write reciprocal sideways here. Okay, reciprocal. All right, so what do I mean by that? The reciprocal functions are essentially the flipped functions. So there's no button generally on almost all calculators for this. You might have a fancy one that has it because you don't really need them. It's just the reciprocal, right? So for cosecant, we generally write CSC. So cosecant of an angle, in this case, is just 1 over sine. Okay, that's all cosecant is. So in other words, it's 1 over y, 1 over the y coordinate. Secant is the reciprocal of cos. So when we flip it, we generally just write secant, SEC for short. It's 1 over cos, which just gives you 1 over the x coordinate, which is the reciprocal. And cotangent is just the reciprocal of tan. So we usually write COT for short. So with these ones, we're not getting too crazy. We're just learning about them a little bit. The main thing right now is to know the 3 primary ones. You still need to know these definitions, but we don't go too far with them yet. We just really got to hammer them down and understand where they come from. All right, so we got our primary functions and our reciprocal functions. So as much as I'd like to linger on this longer, I'm just going to say it one more time. I can't hammer this home enough. Sine and cos are literally the x, well, cos is the x, and sine is the y coordinate from the unit circle. This is where they are taken from. This is their definition. This is their birthplace. Okay? Now, there's infinite possible points on this, and your calculator can help calculate these. Remember we made a unit circle, we found the key points, right? But what if there's certain points, that are, not a key point? Well, then we can definitely use these functions to figure them out. So sine and cos are ultra important, and this is where they are born out of. We use them for all kinds of things, but it's important to those of you continuing math that understand if someone was to say to you, well, what are sine and cos from? Okay, they are the y and x coordinate from the unit circle, okay, given a certain angle, theta, right, or given a certain radian measure, which is the length around the outside, which we use t often for. All right, so let's just do a couple quick examples. This work is pretty easy. Again, this is more about mastering the concept. The work is simple. It's the concepts this week that are more important. All right, we're just going to do a few quick examples. Like I said, the work here is easy. It's a lot of video watching and comprehension this week, okay? So more about the knowledge than the homework. I still want you to try the homework, but it's really getting a deeper understanding of this stuff, or at least a starting understanding is really more accurate. All right, so let's say what we're going to do here is I want to find the 6 trigonometric functions that we just talked about, given each real number t. So what we're saying is imagine we traveled around the unit circle and we traveled pi over 3 around the unit circle. Now, that's the radian measure, right? What if we want to convert that? I'll just write rad for short. What if we want to convert that to degrees, in case we forget what it is? Remember, all you got to do is multiply it by 180 over pi. The pi's will cancel out. 180 divided by 3 is 60. So in degrees, that would be 60 degrees. So it's important that you can go back and forth between the two, right? Radian, that's the length. Degrees, that's the amount of rotation. So what we're going to do is let's jump to our unit circle that we filled in the previous lesson and identify what point is at pi over 3 or 60 degrees. All right, so here's the unit circle I filled in before, and where's pi over 3? Here it is, pi over 3 or 60 degrees. And again, I know I repeat this endlessly. Remember, the radian measure, the pi over 3 is the length. It's pi over 3 to travel around the outside the circle to here. And the reason I repeat this so much because it's so important to understand this, okay? The 60 degree is just how much we rotated from here to here, right? So they're different. Length versus rotation. All right, the main thing though is what's the point? There's that point, 1/2 root 3 over 2. So the terminal point is 1/2 root 3 over 2. So I'm going to take that point back to our homework here. Okay, so the point we got, let me write it down here. We said the terminal point is 1/2, I'm just going to write P for point, and root 3 over 2. Okay, so what I want to do is I want to state the value of the 6 trigonometric functions. So let's do that. Here we go. Let's start with sine. Okay, so sine of pi over 3, or sine of 60 degrees. So what's sine? Sine's the y coordinate. So let me just make this clear. There's our x coordinate, there's our y coordinate. So sine of pi over 3 would be root 3 over 2, right? Or the same thing as if you do sine of 60 degrees. Now, if we were to put this in our calculator, if we put in sine of pi over 3, it would give us the decimal version of this number, right? And we're looking for, of this whole number here. And we're looking for the exact number. That's why we're looking at our unit circle, right? Same thing, if I did sine of 60 degrees, it would give me the same thing, right? But as a decimal. So we want the exact number. So I'm not saying we couldn't use our calculator, but there we go. So there's the first one. All right, let's do cos. Cosine, right? It's the complement of sine. Co, meaning complement. All right, cos of pi over 3, or cos of 60 degrees. That's the x-coordinate, so it's just 1/2. All I did is literally write down the x and y coordinate. That's pretty easy, right? Okay, what about tan? Tan of pi over 3. All right, now, you do have a tan button, right? But again, it's going to give us the decimal version. So remember, what is tan? Tan is the y coordinate divided by the x coordinate. So, in other words, it's root 3 over 2 divided by 1/2. It's the slope of that line going through the origin through our circle. All right, so when I do that, I get root 3 over 2 times 2 over 1. 2's cancel out. All I get is root 3. So that would be the slope of that line, the tangent. Okay, so there's your three primary trig functions, right? We call those the primary ones. Let's do the reciprocal ones, which are the same thing but flipped. So if we're going to do the first one, that would be cosecant, right? So cosecant of pi over 3, all we got to do is take sine and flip it. We need the reciprocal, okay? So let's flip it, and we're going to make that 2 over root 3. Now, we have a little problem here. We need to rationalize the denominator. We're not supposed to have a root on the bottom, right? But that's an easy fix. We've covered that before. We just need to multiply this by root 3, whatever that denominator is. And remember, why do we do that? Because think about what happens. When you go root 3 times root 3, what do you get? You get the square root of 9. What's the square root of 9? 3. So it just cancels out, right? So let me just get rid of all this. So long story short, I can just get rid of this. Long story short, that's a joke, right? This has been so long. This has been a very long story long. There we go. It's 2 root 3 over 3. So there is the proper way to write the cosecant of this. Secant, this one will be easy because all we got to do is flip 1/2. Well, you flip 1/2 and what do you get? 2. 2 over 1, right? So it's 2. And let's do cotangent, which is the reciprocal of tan. What do we have to do? We just got to take this guy here and take his reciprocal, flip it, which gives me 1 over root 3. And the only cleanup, again, I got to do, right, it's pretty simple. Just rationalize the denominator. We want to make the denominator a rational number. So remember, well, maybe this isn't the time to review it. We get this. Why do we do that, though? I'll give you the short answer. Square root of 3 is not a rational number. It's a never-ending decimal, right? So we don't want that, so we want to make it into a rational number, okay? We basically, division without a calculator, I know we all have calculators, but it would be technically impossible to take a number and divide it by an irrational number, or a number that never ends, it doesn't repeat. So we want to fix that and just basically write in proper form. That's the short answer. All right, let's do the next one here. All right, we got find the point. What is that point when we travel, right, pi over 2 around the unit circle? What is the x and y coordinate? Well, if we forget what pi over 2 means, right, we can convert it again. Just times it by 180 over pi, right? The pi's cancel out, okay? And you go, what's 180 divided by 2? Oh, it's 90 degrees. There we go. That's an easy one to find on our unit circle. Let me just jump to our unit circle again. Where's 90? There it is right there. Pi over 2, or 90 degrees, is 1, 0. All right, so there's our point. So you're going to need to look at your unit circle for this. So we got 1, 0. All right, now this one's actually going to be pretty easy. Here we go. What's sine of pi over 2? It is 0. What's cosine, the complement of sine of pi over 2? It's just the x-coordinate. It's 1. What's tan, all right, of pi over 2, right? What's the slope at that point? What's 0 divided by 1? It's going to be 0. Oops, you know what? I messed up. I'm thinking of cotangent here. I put x over y and not y over x. Oops. Sorry, my bad. It's 0 over 1. Oh, you know what? No, I'm realizing there's something wrong here. I wrote the wrong point down. I wrote 1, 0, and it should be 0, 1. I wonder, oh, that's my dog. Sorry, guys, just like in class, I don't have time to go back and fix this and make myself look better and smarter. You can just accept that I made mistakes. All right, sorry that I made that, though. Okay, so here we go. Sine is the y coordinate, which is 1. cos is the x-coordinate, which is 0. I knew something was wrong when I got to tan, and I was thinking in my head of the slope of this line. All right, so 1 divided by 0, right? Well, what is that? That's an undefined number. And I knew something was up because when I think about, right, if we think about our unit circle, there it is, and we were talking about this point right here, right at 0, 1. What is the slope of the line going through the center of that circle there? It's a vertical line. It has an undefined slope. And it was at that moment I realized, oh, I wrote the wrong points down. All right, to wrap this one up, all right, let's do cosecant. All right, that's pretty easy. We just need to flip 1. Well, what's 1 flipped? It's 1 over 1. It's still 1. Here's where things get a little messy, though, right? What do you get when you flip 0? So what do I mean by that? Take the reciprocal. Well, you can imagine that 0, think about it this way. 0 could be 0 over any number, like 0 over 1 or something, right? So when you flip it, now you're going to get 1 over 0, which is undefined. So we got an undefined secant. And again, we haven't got into much of what, all we've really defined are what sine, cos, and tan are. We haven't really talked about what cosecant, secant, and cotangent are, because I don't want to get too deep into this yet, okay? We're just going to take this in little steps. All right, and the last one is cotangent. We just need to find cosecant, secant, and cotangent. All right, cotangent, if you flip 0 over 1, well, what are you going to get? Or 1 over 0, you're going to get 0 over 1, which is 0. So this is going to be important when you're doing a little bit of the homework. Keep this in mind, right? The reciprocal of 1 is 1. The reciprocal of 0 is undefined, and the reciprocal of undefined is 0. Okay, so that'll help you answer a few questions really quickly. All right, one more quick example, and then we're all done. Okay, so we looked at key points. We did some of those key points we found in the unit circle. What if I just give you some more random points on the unit circle? Because the unit circle could have infinite points on it, right? So what if I just kind of came up here and, oops, I'm going to draw a quick little graph here. All right, there, I got a couple little graphs drawn. All right, so what if we have the point 3 over 5 and 4 over 5, right? Well, if we want to write those as decimals, 3 over 5 is 0.6 and 4 over 5 is 0.8. And they're both positive. So this point is somewhere, you know, it's like if we want to get technical, right, it's 0.6 over. So a little, you know, here's half, right? Because again, our radius is 1. So if you want to get technical, it's a little bit past half. And up here, if you want to, you know, I'm not going to worry about getting it too accurate. And when you draw sketches, you don't have to be super accurate. We just want to get in the right quadrant, right? So there it is. Don't forget our radius is 1. Right, there's that point, 0.6, 0.8. All right, well, let's just once again do the 6 key trig functions, all right? And we're going to do it with the fraction, not the decimal. So don't forget, when we're doing that, sine and cos are defined by, cos is the x-coordinate. The length from the y-axis across is what cos is. And sine is the length from the x-axis vertically up to that point on the unit circle. So that's what they're defined as, okay? This is where they come from. That's why I'm really hammering this home to understand that. So they're going to say, now we don't know if we've traveled t or theta, so we can use whatever. I'm just going to say we've traveled some angle theta, right? I know it's a super tiny diagram here. There we go. All right, so let's do sine of theta. Okay, so whatever theta is, we don't know, but we know we've traveled, the y-coordinate is 4/5, right? Because that's what that is. Sine is just the y-coordinate. Cos is going to be the x-coordinate. So that's all it is. Now, we could actually use this to figure out the angle, and we'll do that in 1 second. I'll show you, right? Well, you know what? Let's do that right now. What if I want to know the angle that I've traveled, or the radians? All right, so this is a good time to pull out the calculator, because we are going to get into this pretty soon. All right, so let's do sine of 4/5. So I'm going to go, well, what's 4 divided by 5? We already figured that out, right? Which is 0.8. And let's use our trig buttons on our calculator. I'm going to hit sine. Look, it gives me 0. Oh, am I in degrees or radians here? Hang on 1 second. Oh, geez, do I feel like a doofus? Hang on here. I know what I did wrong. Man, it's like I'm falling asleep. All right, let's just look at sine for a second here. I think I am. All right, so let's say we want to solve for theta. We could use sine, we could use cos, we could use tan. Let's just use sine. What I didn't do, I hit sine. I have to use sine inverse, right? I want to get rid of the sine on this side. I'm sure a lot of you are shaking your heads at me. Sorry, I've been recording videos for you guys and all my other classes all day. I'm falling asleep. There we go. So if we do sine inverse of 4 divided by 5, I was hitting sine of it, and I'm like, wait, why am I getting this tiny number? Of course. So 4 divided by 5 is 0.8. we're going to go second, or we have to hit second in here, sine inverse. There we go. And notice we get 53.1 approximate degrees. So there it is in degrees, 53.1 approximately. So that's how far we traveled to get to that point, right? I know it's tiny, but that's what that angle would be. We could also find out the length that we've traveled, right, around the outside. Now, to do that, let's clear it out here. I'd have to switch from degrees to radians. And let's do the same thing. 0.8 is the y-coordinate. Okay, let's hit trigonometry here. Let's hit second, and let's hit sine. And we get 0.927, so about 0.93 radians. So the distance around the outside to get there, about 0.93 radians, right? That is the length of that piece of string. So it's almost one radius, right? Our radius is 1, so it's almost 1, but it's not quite as long, all right? So that's how we could find that. So that's just sort of a little side of what we're heading to, right? The idea that I could solve for that angle, or I could solve for t, that length around the outside, okay? All right, so if I want to be specific, I really would normally label this with t for my radian there. Okay, let's keep rolling though. So you could use cos to find that. We could do the same thing by, if we did cos inverse of 3/5, we'd get the same result. We could also use tan to find this out. Now, the more we learn, there's going to be some different stuff we're going to learn about this, but we'll keep it simple for now. All right, so tan is the y-coordinate divided by the x-coordinate. All right, so we just got to simplify this. So what's 4/5 times 5/3? 5's cancel out, and we get 4/3. All right, so there's our first 3 primary trig functions. Sine is 4/5, cos is 3/5, tan is 4/3. Let's find the inverse functions really quickly. Nothing too difficult there. We just got to flip them. All right, so cosecant, which is the inverse of sine, is 5/4. Secant, which is the inverse of cos, is 5/3. And cotangent, which is the inverse of tan, instead of 4/3, is 3/4. Pretty simple, right? All right, so there's our first one. I just want to do one more here because I picked one that's a little easier and then one that's a little more difficult. All right, so last one. Here is the x-coordinate. Here's the y-coordinate. Let me just make this circle just a titch bigger here. The last one was a little too tiny. Okay, so now we have a negative x-coordinate and a positive y-coordinate. So where is that? That means this point is somewhere over here in the second quadrant, right? We've traveled around this far. So now it depends on, are we doing degrees? That's the rate, or the are we doing radians, the length around the outside t? Either way, we end up at that point, right? All right, so let's identify our sine, our cos, our tan. Move this along. Sine and cos are super simple. Sine is going to be √13/7. Cos is going to be -6/7. And tan, we'll have to be a little more careful. Y divided by x. √13/7 divided by -6/7. All right, so when we do that, we're going to have √13/7 times, we're going to flip this, -7/6. Obviously, the 7's cancel out, and we end up with -√13/6. Now, it makes sense that the tan would be negative, because think about, what is the slope of a line going through here, right? It should be a negative slope, and we do have negative for tan, because that's what tan is. All right, so again, tan right now is going through your point, going through 0, 0, and going through your point, right? What is the slope? Not length of that line, the slope. Sine and cos give you the lengths. All right, so let me just highlight those. Sine, cos, and tan. All right, to finish it up, let's find the reciprocals. So cosecant. Now we're going to have to be careful because we're going to flip this, and now it's going to be 7/√13. All right, so once again, we need to clean it up, but to rationalize the denominator, we just need to multiply by √13/√13. All right, and when we do that, we end up with 7√13, over 13. There's the first one. All right, let's flip cos. The reciprocal of cosine is secant, which is SEC for short. This one's easy because -6/7, we just flip it. It's -7/6. All right, so that one was simple. And the last one, we are going to flip cotan, or flip tan, and make it into cotangent. All right, so we just got to flip this one here, right? And we end up getting -6/√13. Last time, we got to rationalize the denominator, √13/√13. And for cotangent, we end up getting -6√13/13. All right. So those are the values we would get for sine, cosine, tan, cosecant, secant, cotangent. All right, so that ends a pretty long series of lessons. Again, the work's pretty short, but it's very conceptual stuff, and you're really, if you want to continue in math, take some time, watch these videos, maybe even again in the future, maybe even next year. I'll leave them up, and check them out again if they help. Okay? Thanks.